Hello and welcome back everyone. It's been a while since my last video, but playing in the shed is not the only thing I get to do in life, unfortunately. When you need to support long work or hold an awkward workpiece to machine a steady band, there are limited ways of supporting the work to be able to do that. On YouTube there are several videos from other channels who have made rotating tailstock chucks. Makers that come to mind are Curtis, Matty and Max amongst others, all who have made great builds of rotating tailstock chucks. I've already built 5C and ER40 collet mounts for Toolmaster, so I reckon this will be an ideal build that would add significant versatility to the big lathe. I have several Toolmaster chucks and I quite like them. My lathe came with a 320mm Toolmaster 4-jaw and that's a great chuck. I did think about using 200mm chucks as these are within the capacity of the lathe. However, I decided on 160mm chucks as they will be large enough for any work I could think of, and my tailstock has a Morse taper 4 and not a Morse taper 5. A project like this needs to start with a drawing, and as usual I used Excel to produce a concept of how I see the build. I like Max's design and I'll be using this as a starting point for my build, with some changes to include my own ideas. So, fair's fair, design attribution to Max Grant. As usual, the plan will be subject to change as the build progresses. I will be using Timken 32007X taper roller bearings. These have an outside diameter of 62mm and an inside diameter of 35mm. The lip seals are standard 62x40 and they're 10mm thick. The 4-jaw chuck has a 65mm register, which is too close to the bearing outside diameter size, leaving not enough metal to form an effective register. So I plan to make a register ring to fit the chuck and recess into the hub after the bearing and the seal are installed. Prior to starting, I 3D printed a prototype of the 4-jaw hub. This gave me a feel for how the register ring would work. It's my first 3D design, but you get the idea, right? I already have the steel, but I'll need to buy the chuck's bearings and seals. I have a piece of 1214 bar stock that was left over from a previous project. It's the butt off along the bar, but as I need to machine one end down to 80mm, it will do perfectly for this job. I've seen some people make the hub from two pieces welded together, however I'll be making mine from a single piece of bar stock. The 4-jaw hub will be made from a piece of 120mm diameter 1214 grade, and the 3-jaw hub will be machined from a piece of 170mm diameter 1045. I'll be showing the build for the 3-jaw chuck. The 4-jaw will follow each step of the build to preserve setups, but I'll only show one of the builds in the video. I changed the bandsaw blade to a coarse one, and that makes short work of cutting the bars to size. Well, reasonably short work. The cut pieces look fine and they're quite heavy. Time to start converting perfectly good steel into swarf, chips and plenty of 6s and 9s. But first I need to install a 4-jaw. As these chucks weigh more than 40 kilos, I use a crane and a come-along to help lift and change them. I made a cam lock spanner specifically for this lathe. No need to over tighten the cams, but this tool has a lot more feel than the T-spanner that was supplied. I also have one for the other lathes. In my opinion, they're a must-have. I'll start by facing the end and taking a sliding pass so I can turn it around in the chuck and have a square end that I can reference for other features. I'm using a WNMG insert to do the roughing. I did think about using the 4-jaw standoffs, but they were not needed as this is only a rough face and is not yet a reference surface. The hole needs to be taken to a diameter of 55mm. This will provide clearance for the axle, which will be 35. played around with the feeds to get the chip to break, and then turned on the coolant so I could finish it to size without waiting for it to cool. I think it might be time to change that coolant. I changed to a TNGG for the last few finishing cuts, and just look at the difference in surface finish. But the swarf, target is 80mm, and that's what I got. I use an RCMT 10mm button insert to round the corner and face the flange. It can remove metal in a large cutting area, but the swarf is certainly not friendly. To cut the bearing seat, I'll use the carriage stop I made in a previous project. It's useful when machining to a blind shoulder. I just set the carriage to the final depth, then lock the carriage stop. Back the saddle up 0.5mm and reset the thimble. Now I can stop the feed at the depth -1mm for all the roughing cuts before hand feeding to the stop. Then for the final cut, I can reset the thimble to the final depth, then stop 0.5mm short before hand feeding to the stop. This ensures that the bearing seat will be exactly the depth I want. The bearing seat needs to be an interference fit for 62mm. This will provide a seat for the bearing cup and still allow the opportunity to remove it later should there be a need to replace the bearing. The target diameter is 62mm plus 0 minus 0.003. I don't have any soft jaws to protect the finished machine surfaces on the hub when I turn it around in the forejaw, so I need a side project to make some. I have a length of copper tube and I'll cut a few pieces and flatten them in the press to make soft pads. they'll do nicely. To align the flange on the chuck, I need to reference two of the machine surfaces. The DRO on the flange shows barely a flicker. I didn't expect that. How much is due to the slightly rougher surface I'm not sure, but I'm not prepared to push it any further. Again, I'm using the carriage stock while machining the bearing seat. The target diameter again is just shy of 62mm, the same as the other end. All that remains now is to turn the register for the chuck, which is 135mm, then bring the flange to final size. I'll finish off with Brandon's all round. I've waited for a long time to get this tool holder and it's perfect for this job. I set up the hub on the table and centered the spindle. It was nice of the camera to decide to run out of electrons, so I didn't get to capture the centering of the spindle. I'll set the DRO to a radius of 71 and the number of holes will be 3. Start and finish angles are of course 0. Starting with hole 1, I'll spot each hole with a spot drill, then go around with a tap drill followed by a chamfer for each hole. Lastly, I'll tap each hole and the hub is complete. Clean up with the vacuum cleaner and we're done. If only changing chucks was that easy. I'm using a piece of 80mm 4140 as I don't have anything else that size suitable for the register ring. The reason for the 79mm is to allow me to turn the bar with a finishing cut. Machining off 1mm allows me to do that. The step down is to match the register in the chuck, and that is 65mm. I'll use the 13mm drill followed by a boring bar to plough a hole and then part it off. I don't want the hole any deeper than necessary, as that would waste the remainder of the bar stock. Well, that's about it for this part of the project. I now have the project complete, so it's a matter of editing the final part. I'll have that posted shortly, so please keep tuned. As always, thank you for watching. I appreciate you giving some of your YouTube watching time for my projects, and I hope you found this of value. Don't forget to check out the other videos I referenced at the beginning of this video, and for a full comprehensive description and commentary, check out Max's video series on his tailstock chuck build. I'll put links to all of these in the description. Keep watching for the final part. In the meantime, be productive, be creative, but most importantly, be safe in your shed. I'll catch you next time.